Welcome to 1-4's video where our lesson essential question is, how can I apply the distance formula on the coordinate plane to classify quadrilaterals? So in our in-class investigation, we had quadrilaterals that were evenly on the grid, where I could count easily 1, 2, 3, 4, and 1, 2, 3. But I don't have that. This is at a slant, and I can't just count 1, 2, 3. It's not going to be the same length. So can I classify this quadrilateral as a parallelogram? Well, to do that, the sides have to be parallel. So I can start at HG, and I can say, well, I'll go down 1, 2, 3, over 1, 2, 3, 4. And then I can check, is EF the same? So I go down 1, 2, 3, over 1, 2, 3, 4. So those sides are parallel. I'm going to check the other side now. I'm going to start at H and go to E. I'm going to go up 1, 2, 3, 4, over 1, 2, 3, up 4, over 3. And then I can check GF. And I can say I go 1, 2, 3, 4, up 4 over 1, 2, 3, up 4 over 3. So I can say that this shape, EF, GH, is a parallelogram. The next thing is, how can I classify it as a rectangle? Going back to this, rectangles have all right angles. So I can just see, are these going to form right angles? Well, right angles are perpendicular lines, and perpendicular lines, when graphed, have the negative reciprocal slope. And if I take negative 3 over 4 and I switch it, so it's now 4 over 3, and then I add a negative, yeah, that's the same. So yes, because the slopes are perpendicular. What would I need to know to classify this as a square? Well, a square would be a parallelogram that has all the same side lengths and the same angle measures. So I just have to prove that all the sides are the same. So if you're on a graph, I recommend using the Pythagorean theorem. You've already done a similar thing. I'm going to draw a triangle like this. And I can count 1, 2, 3. So side A is 3, and then 1, 2, 3, 4. That should be negative 3 actually. And B is 4. So I have A squared plus B squared equals C squared. And I have negative 3 squared plus 4 squared would be 9 plus 16 equals a 25. So then 25 is the same thing as C squared. Square root both sides to get C by itself, and C is 5. So I know EF equals 5. Very simple. What we're going to do is explain how the distance formula really is the Pythagorean theorem. So if I have a graph here, and I'm just going to make some points up here, I'm going to say that this is 2, 1, and this would be 5 and 4. So if it's on a graph, as it is, I can say, well, if I go from 2 to 5, that would be 1, 2, 3. And I could count up from 1 to 4, and it'd be 1, 2, 3. So it'd be a 3 and a 3. But the distance formula has me looking at the point values, not the graph. So I'm going to look at my x values, and I'm going to have d equals the square root of 2 minus 5 plus 1 minus 4. And those are all squared. And 2 minus 5 is 3, and 1 minus, that's negative 3, and 1 minus 4 is -3. Those are both squared. And I'm going to get 9. So I'm going to get 9 plus 9. And then that's going to be 18. And I remember it's square rooted. That's the same thing. If I had a squared plus b squared equals c squared, well, I'm going to have 3 squared plus 3 squared equals c squared. 9 plus 9 equals 18 equals c squared. Take the square root, and it's the square root of 18. So when I want to use the distance formula is probably when I only have the points given. Like, hey, here are the 2 points, find them. Find the distance between them. The x1 and x2, it doesn't matter if this is x1 or this is x2. You just got to make sure you keep x2 and y2 together. So, the distance formula is a modified Pythagorean theorem. So, I want you to pause the video, use the Pythagorean theorem to find the distance between these 2 points, and then use the distance formula to find the distance between these 2 points. If you don't get the same number, you made a mistake, so, figure out, ask some questions. Okay, welcome back. So, if I go x1, y1, x2, y2, going from x1 to x2, if it's a 2 to a 4, that means this is 2. Going from a 1 to a 5, that means that would be a 4. Then I square it, so I have 2 squared plus 4 squared. I get 4 plus 16 equals 20 equals c squared, square root, and c is the square root of 20. And I can just leave it like that. If I'm going to do Pythagorean theorem, I have my points. I do x2 minus x1. x2 is 4 minus 2. That's all squared, and that's going to be 2 squared. Oh, look, I had a 2 squared. Plus y2 minus y1, that's going to be 5 minus 1 squared. That's going to be a 4 squared. So that's going to be 4 plus 16 equals 20, and it's the square root. So it's the same number. So going back to, is this a square? If I find that all these sides are the same, then yeah, it'd be a square. And I have all these points here. But I don't have to do all of them. I already know that this side and this side are parallel, and this side and this side are parallel, making it a parallelogram. And one key factor of parallelograms is that the opposite sides are the same. So I only have to prove that 2 of the adjacent sides, either those 2, or these 2, or these 2, or these 2, any of 2 adjacent sides. Because if these 2 are the same, then we already know that the opposites are the same. To help you do this, there's a sheet. I'm going to need to only identify my x1, x2, y1, y2, and then it just flows down together to give me distance. So I'm going to do these 2 points. I'll do one, and you can do one. I'll do EF, and I want you to do EH. So EF would be these 2 points. So I'm just going to put in my points as a 2 and a 3 and a 6 and a 0. It's identifying them as x1, y1, x2, y2, and then I can just put x1 and x2 in here, so it's going to be a 6 minus a 2, and then a 0 minus a 3. Then I can say, what's 6 minus 2? 4. What's the 0 minus 3? -3. Then I can square it. 4 squared, 16. -3 squared, 9. Add together, 25. Distance is 5. So I want you to pause the video and you do the other point, the other side. So you guys had to do EH. So I'm going to put my points in. I'm going to have -1 and -1, 2 and 3. Then I look at x2. x2 is 2. x1 is -1. Then I have y2 as 3, y1 as -1. For both of these, it's minus and negative, so it's going to be plus. So I have 2 plus 1 is 3. I have 3 plus 1 is 4. Squaring 3 gives me 9. Squaring 4 gives me 16. Adding together gives me 25. Square root of 25 is 5. So these two are naturally the same because they're opposite sides of a parallelogram. These two are naturally the same because they're opposite sides of a parallelogram. And then all four of them are the same because I found that the adjacent sides are congruent by once earlier using the Pythagorean theorem, but also using the distance formula. So you're going to need to basically be able to explain how to use the distance formula in your Learning Essential question check-in. To get you better at that, there's a Delta Math, which is 1-4, and then 2 Matthew workspaces where it's going to help you learn the distance formula. Happy solving.